What is up, guys? Today I'm going to be showing you how I designed and built a controller for a golf simulator. So my parents are currently building a golf simulator, and I've been to a few commercial golf simulators, and all of them have some kind of control unit on the ground so that you can do things like aim left to right, or change your club, or look at the green, and different things like that. So when I started looking online, I saw two problems with the ones that you could buy. First of all, you couldn't really pick what buttons you wanted. You were kind of stuck with whatever the designer thought were the best options. And second of all, they were pretty expensive. The ones with the smaller buttons were the cheapest I could find was around $100, and the ones with some bigger buttons like this were up to $150 to $200. So the total cost I was able to build this for was just under $75. Now I do want to mention, if you want some more information on the materials used, how I wired this, and including the 3D print files, I have a link to my GitHub account in the description, and that will take you to my GitHub page that I have for this design. If you want to do this exact build and don't have your own 3D printer, you can purchase this box from me. I will leave my email in the description as well, and you can send me an email saying that you want to purchase this box, and we can work something out. So first, let's get into the box. This is basically the max size that my 3D printer can print, so that's why I chose this. I would maybe have liked it to be a little bit bigger, but this still works. So I have the box here, and then I have what each button does below them in a different color, and I embedded that into the print itself so it's not sticking out or anything, and it's easy to read. Now for the brains of the box, I decided to go with a ESP32 dev board microcontroller. Now the reason I chose this was, one, because it was cheap. It was only about $10, and all I needed to do was have 9 pins and also have a Wi-Fi and Bluetooth connection so that I could connect it via Bluetooth to my computer and not have any wires coming out of the box itself. Now for the buttons, these are 60mm arcade style buttons. I opted to go with the bigger buttons because I think it'll be a lot easier to restyle and hit with your club. A lot of the ones I saw for sale were using the standard 30mm arcade buttons, and I just thought that that would be kind of difficult to go down and make precise clicks with your club when you're trying to click them. I also like these because they have a screw on the back, so it was easy to kind of just insert them in here and screw them tight so that they don't move around at all. And lastly, if you hook these buttons up to a 12-volt power supply, they also have LED lights in them so that the buttons themselves light up, and makes them easier to see because usually when you're in a golf simulator environment, it's dark so that the projector can be brighter. Now before I turn this around and show you guys the wiring, I do want to have a disclaimer. I don't necessarily recommend this, and if you do it this way, do it at your own risk. I'm not responsible for any shorts or fires started. So here is the back of the board.
Oh, these aren't homemade. They were made in a factory. A bomb factory. They're bomb.
There are 36 wires in total running around in here. 9 buttons, 2 wires for each button that go to the microcontroller, and 2 wires for each button that go to the 12-volt power supply to light up the LED inside the button. Now I opted to go with the breadboard approach so that I didn't have to solder any of the wires directly to the microcontroller. Looking back, I probably would have just tried to solder it, even though I've never done that before, just because this kind of ended up messy. So what I ended up doing was getting these spade connectors to connect to the actual button themselves. And when I first ordered them, I don't know why, I just thought that the other side was going to have like a jumper wire connection, but it was just bare wire. Now, if you were soldering this directly to the microcontroller, that wouldn't be a problem at all. That'd be what you wanted. However, since I was using a breadboard, this was a problem. So my solution to this was I took the jumper wires from the breadboard, I cut them in half and soldered it to the other end of the spade connection wire. So that gave me a spade connector on one end to go to the button and a jumper wire connection to go to the breadboard on the other side. Next, for the 12-volt power supply to light up the LEDs, I used the same spade connectors to plug into the button, and then I had some old extension cord laying around that I had already cut up. So I cut off a piece of that. I soldered all of the ground connections to one wire and all of the live connections to the other wire, and then plugged that into my connector that goes to my 12-volt power supply. Now again, I'm sure there is a better way to do this. Please let me know in the comments if you know a better way, but this is how I did it, and it does work. And now I'm going to give you kind of a close-up of how you actually connect these wires to the button. So as you can see here, this is what goes into the button. These two are for the microcontroller, and these two are just what controls this LED. So this top one is your communication wire, so you want that going back to the pin on your microcontroller, and this is just the ground for that. And then for the actual LED, this blue side you want to be your live wire, and the other side you want to be your ground for the 12-volt power supply. So again, if you are copying this build and want to use my exact code copy and paste, you are going to have to plug in the buttons to the exact same GIO pins on the dev board, which all that information is in the GitHub. So with all of that information out of the way, I'm going to take this thing out to the golf simulator and show it working. All right, so we're on the bar now. Obviously this is a little bit of a janky setup, but I have the two connections plugged in there, and now the lights are on and the board is functioning. So this is what it looks like on the ground with those lights on. All right, so here's a golf simulator. As I said before, still a work in progress, not completely done. When it is done, I might make a video on it, explaining the design choices and kind of how to build your own. But here we are, famous hole 16 of the waste management, and my control box is here on the ground. So as you can see, I'm gonna reach down, you can hit aim left, aim right. You can reset your aim, it goes back to where it was. In the bottom left, you can see my club. So as I club up and down, it changes my club. I can see a heat map of the green. I'll change there, you can't really see that. I'll leave it on as I fly over. And then we have the shot cam button, which kind of zooms in and shows you how far you have to hit it to the hole. We can go off that. The mulligan button, I can't really show you because I'm not going to hit, but trust me, it works. I've used it plenty of times already. And then lastly, we have the flyover button, which just gives you a nice flyover of the hole. So thank you guys for watching the first video on the new Built by Reese YouTube channel. I'm going to be posting more videos like this of custom builds with microcontrollers, different 3D print designs, some smart home stuff, along with any just general tech videos. So don't forget to like and subscribe, and I'll see you guys in the next video.